Okay, let's talk about subsets. So a subset is defined that if every element of a set A is also an element of set B, then we can say that A is a subset of B. And we write this as, and then here is your symbol for it. It's A, and then it almost looks like a less than or equal to sign, except it's curved. So that's the subset symbol. That says A is a subset of B. A proper subset is if you have A and B are sets such that A is a subset of B, but A doesn't equal B, then A is a proper subset. And again, you write that as A, and then almost like a less than symbol, again, but it's curved. It's like a sideways U. So A is a subset, a proper subset of B in that way. And then we need to define an empty set. This is a set that contains no elements. It's called an empty set, and it's denoted by basically a circle with a slash through it. The empty set is considered a subset of every set, so that will be important. Any set, you can say that the empty set is a subset of that. So we've got some special notes here. Whoops. I'm drawing when I don't mean to. Okay, so some special notes. You have to be very careful when you use your notations now, and this is something that catches a lot of students if you haven't worked with sets before. Subset notation does look a lot like inequality notation, but you cannot interchange the two. So that subset of and the less than or equal to symbols are not the same. So you can't just replace one with the other. One is curved, one is pointed. They are not the same thing. One talks about sets and the other one refers to elements or objects or numbers. So they are not interchangeable, even though they seem similar. And the one that really gets students is that you have to now be sure not to confuse the empty set and the number 0. You cannot use the circle slash notation instead of the number 0 because one of these is a set and the other one is a number. And these are different things. Sets and numbers are different things. Numbers can go in a set, but sets and numbers are not the same. So if you have a habit of writing your number zeros as circles with slashes through them, you have to break that habit now. Because if you write that, I will interpret that as the empty set, even if you mean the number 0. We will not be speaking the same language anymore, and it will be counted incorrect if you write your zeros with the circle and the slash. So just if you have that habit, try to break that right now and make a new habit. And I know that I don't know where that comes from, where we pick that up from, but somehow we do. Okay, so let's practice using these subset notations. So we've got 3 different sets here, A, B, and C. A is the set of the numbers 1, 2, 6, 7, and 8. B is the set of the numbers 1, 6, and 8. And C is the set of the numbers 1, 2, 5, 6, and 7. And we want to choose which of the following statements are true. Choose all that apply. Okay, so the first question is A a subset of B? So is every element of A in B? That's basically the question. So let's see. 1 is in A. Is 1 also in B? Yes. 2 is in A. Is 2 also in B? No, it fails right there. So the answer here is no. A is not a subset of B. I'm going to erase those markings. Is B a subset of A? Does it work the other direction? Is every element in B also in A? So 1 is in B, 1 is also in A. 6 is in B, 6 is also in A. 8 is in B, 8 is also in A. So in this case, it works. B is a subset of A. So yes on that one. Gonna erase my markings. Is B a proper subset of C? So the proper subset means that it cannot equal it. So I can look at those two and I can say B definitely does not equal C. They are not exactly the same. They do not have exactly the same elements. So that part of it's okay. Are all of the elements in B also in C? So 1 is in B and 1 is in C. 6 is in B and 6 is in C. 8 is in B, but it is not in C. So this one fails again with an answer of no. B is not a proper subset, and it's also not just a subset. So I can say no again on this fourth one because I just showed that all the elements in B are not also in C. So that one I kind of got for free there. Okay, let's start over. Is B a proper subset of A? Well, I've already shown that it's a subset, so the only additional thing I need to check to make it a proper subset is, are B and A not also equal to each other? And they're not. B and A do not have exactly the same elements, so this one is also a yes. B is also a proper subset of A. Is A a proper subset of A? Go back. Is A just a subset of A? So that is basically saying, is every element of A also in A? Well, that's almost seems like a silly question to you, right? Because I could go through and say 1 is in A, yes, 1 is in A. 2 is in A, yes, 2 is in A. 6 is in A, yes, 6 is in A. Same for 7 and 8. They're both in A, and they're both in A. So, yes, A is a subset of itself. Is it a proper subset of itself? A proper subset would mean every element in A is also in A, but it doesn't equal itself. So that one would be a no. Might seem like a silly question. That's like similar to asking, is 5 less than 5? No. So we get out of this that every set is a subset of itself. So I can always say it's a subset. A set is a subset of itself, but it is not a proper subset of itself. So I'll add that there. But not a proper subset of itself. Okay, so let's see. If B equals the set of elements 7, 10, 13, 17, and 20, Part A says, write a set such that A is a subset of B. So we have lots of options here. I just want to write one subset A so that it's a subset of B. So I'm going to say A equals. I just need to write down some set so that every element in it is also in B. So maybe I just make it the set of the element 7. That would work. 7 is in A and 7 is also in B. I could make a different set A that is just the element 10, perhaps. 10 is in A, 10 is also in B. Or I could do any combination. So there are lots of choices here. Maybe I do A is the set of elements 7 and 20. Well, that would pass because both 7 and 20 are in A, and those are also in B. Okay, so there would be lots of options there. The next part says, write a set C such that C is not a subset of B. Okay, so I need to come up with a set C so that every element in it is not also in B. So why don't we just pick an element that's not in there? I'm going to choose the number 5. If I have a set C that is just the number 5, well, that's definitely not, 5 is not in B, so that would pass there. And again, you could come up with hundreds and millions of examples if you wanted to. Write a set D such that D is a subset of B and B is a subset of D. Okay, so we need to write a set so that every element in it is also in B, but also that every element in B is in D. And you might see where this is leading. The only way this is going to work is if we write the exact same set down. So I'm going to say D is the set of the elements 7, 10, 13, 17, and 20. So every element in that is also in B, and then I could reverse it around and say every element in B is also in this new set D. And what that leads us to is, what does it mean for sets to be equal? So two sets are equal, and we could write them as A equals B, if and only if they have exactly the same elements. They are equal if and only if A is a subset of B and also B is a subset of A.